Hi, this is Professor Jamation at California State University, Long Beach. In this video lesson today, we'll look at the addition and subtractions of rational expressions. Now, typically, the concept of addition and subtractions of rational expressions is a little bit more difficult than multiplying and dividing rational expressions. So we'll look at the following examples to motivate. A very, very simple example to motivate here. Let's consider 1/2 plus 1/4. Well, we know the answer to this question very quickly because I can convert this into a decimal expressions, and 1/2 is 0.5 and 1/4 is 0.25. So I add these two expressions, I get 0.75 here, which I know the rational expression that corresponded to this is simply just 3/4. But on the other hand, think about what you would want to do when you want to add two fractions. It's very, very tempting to simply just add the top and add the bottom. So if you do that, we say, well, we just get a 1 plus 1 divided by 2 plus 4. Is that really the same as what we got at the end, which is 3/4? Well, 1 plus 1 is 2, and 2 plus 4 is 6. So if we do that, we would get 1 over 3, which is, in decimal expression, 0.67. Obviously, that's not the same. So in general, we say that A over B plus C over D is not the same as doing A plus C divided by B plus D. Well, then how should we think of 1/2 plus 1/4? Let's consider this following graphical representation. We've considered this as a whole, which is 1, and then 1/2 is by dividing it into two pieces. So the first portion right here is 1/2, and 1/4 is to divide the entire piece into 4 equal pieces, and that the first portion is a quarter. Okay, and notice that 1/2 actually consists of 2 of the quarters. So I can think of 1/2 as 2 times 1/4, which means I can think of as 1/2 plus 1/4 as 2 over 4 plus 1 over 4, which altogether gives me 3 over 4. Now that both expressions are written in terms of a fourth, we can then simply just add the number of fourths that we have. So that's why we get 3 over 4. What happened here is that this number 4 is called the least common denominator. So next, let's actually describe the strategy of finding the least common denominator. In general, to find the least common denominator, also known as the LCD, we take the following strategy. Step 1 is we're going to factor each denominator and then take each distinct factor, then assign the highest power to any factor. Eventually, we're just going to form the product. In our example of the 1/2 plus 1/4 here, step 1 we say to factor each, but 2 is already in its completely factored form, and 4 is written as 2 squared. Then the next step is to take each distinct factor, which in this case is just a 2. So the LCD would simply just be 2, and then assign the highest power that appear in any factor. The highest power is 2 in this case. And so the LCD altogether is 4, and that's why we wrote each expression in the denominator of 4. Next, let's look at a more complicated example here. We have 3 divided by x minus 1 plus x over x plus 2. The LCD in this case would be x minus 1 times x plus 2, each raised to the first power, because both expression here, it's already in a completely factored form, and they're distinct from each other, so we need to take one of each from them. And then the next step is to figure out how to write your original expressions into the LCD form. So we examine the first expression. You notice that in order to write from x minus 1 into the LCD, which is x minus 1 times x plus 2, you need to multiply the top and the bottom by what's missing from that, which is x plus 2. And for the second expression here, in order to write it x plus 2 into the LCD, I would need to multiply the top and the bottom by the missing term, which is x minus 1. So then on top we get 3 times x plus 2 plus the x from here times x minus 1, all divided by the same LCD, which is x minus 1 times x plus 2. So this is really just a task of reducing the top portion by distributing factors. So I have 3x plus 6 plus x squared minus x, all divided by the same LCD. And I have x squared on top, that's the only squared term, and I have 3x minus x as the linear term. So combine those two, you get plus 2x, and we get the only constant term of 6. Now, typically you wanted to examine one more step, just to make sure that the top portion is not factorable. And in this case, it's not factorable over the real numbers. So that means this expression cannot be reduced any further, and that's how I will leave my answer is. Well, let's practice a few more examples just to make sure that we're familiar with the techniques here. Here we're going to do a 1 over x squared minus 1 minus a 2 over x plus 1 quantity squared. I'll pause the video for a second and do this yourself before you come back for answers. You need to factor the first fraction here because this is not in a completely linear factor form. So this is actually the difference of two squares, which can be factored into x plus 1 and then x minus 1. The second expression here is already in the factor form because it is the distinct factor of x plus 1 raised to the power 2. So here we have the distinct factor of x plus 1 and x minus 1. However, for the x plus 1, we have the highest power of 2. So this gives us the LCD. And from the first expression here, what's missing from the LCD is the extra factor of x plus 1. So that means I need to multiply the top and the bottom by the x plus 1. For the second expression here, the missing term would be x minus 1. That means I need to multiply the top and the bottom by that. And then so on the top, from the first expression, I have 1 times x plus 1. Second expression here, I have 2 times x minus 1. There is a negative 1 that connects those two, and subtraction sign there, and I have the same LCD that they share. And then to simplify the top, I have x plus 1 minus 2x plus 2. Remember that you're distributing a negative 2 inside of negative 1 there, so that becomes positive 2. And simplify the top, we get negative x plus 3. Typically, people like to write in the positive expression, so it's going to reverse the order of the 3 and the negative x, so it looks a little bit nicer. So then it becomes 3 minus x over the same LCD term. The reason why I can just write LCD here for my final answer is because I actually have to find LCD somewhere else in my work. So I can actually refer back to that, and it hasn't changed in between, so we can use that expression. Now let's look at one more example here for practice. Here we have a problem with 3 expressions. The technique is exactly the same. You still factor and assign highest power, and then just do the manipulation with the numerator. Okay, so go ahead and pause the video for a second and come back for answer. Alright, again, the only thing that we need to really factor is this guy, the difference of 2 squared. And each distinct factor we have here would be minus 1. And I have another distinct factor of x plus 1 with the highest power of 3 that appear from the first fraction. Okay, and then you go back and examine what's missing for each one of those. So the first expression, what's missing is the x minus 1. That means we need to multiply the top portion by x minus 1. The second expression there, it's missing a x minus 1 as well as a x plus 1, because it currently has power of 2, but we need 3 overall. And the third expression there was missing a x plus 1 squared, because currently it has only a power of 1, but we need 3. And go ahead and then just simplify the top portion. I have from the top a 1 times x minus 1 minus 2 times x plus 1 times x minus 1 and plus 3 times x plus 1 squared. And I'm just going to do the algebra to simplify those. I have x minus 1 minus, I'll be careful here, I'm going to leave the 2 outside and then do multiplication with these two terms first. I'm going to notice that that's actually the difference of 2 squares. That's x squared minus 1. And same thing, I'm actually going to deal with multiplying this first and leaving the 3 outside. I have x squared plus 2x plus 1, all divided by the same LCD. And then I'll distribute a constant term inside to get x minus 1 minus 2x squared plus 2 plus 3x squared plus 6x plus 3. Okay, look for the highest power term, which is x squared. Here I have a negative 2 plus 3, altogether a positive 1x squared. Then I look for the linear term here. I have 1x and a 6x, gives me altogether a 7x. For the constant term, I have negative 1 plus 2 and plus 3, which gives me altogether a plus 4. Again, you're going to look for factors from the numerator here, but there is no way we're going to get this expression to be factored over the real numbers, which will just one more step. We get x squared plus 7x plus 4 divided by the LCD, which is x minus 1 times x plus 1 quantity cubed. And that's it.